All right, we're looking at 8.2, L'Hopital's rule for number 19 in the homework. And we're taking the limit as x goes to 0 from the right of the cosecant x minus the cotangent of x plus the cosine of x. So let's just plug it in and see what we get. So the cosecant, of course, is 1 over sine of x. Cotangent is cosine x over sine of x. And cosine, of course, is just cosine of x. And so if we go to 0 from the right, that's 1 over the sine of 0 minus the cosine of 0 over the sine of 0 plus the cosine of 0. And 1 over the sine of 0. The sine of 0 is, of course, 0, so that's 1 over 0 minus 1 over 0 plus 1. And so really the key here is you get infinity minus infinity, and then the plus 1 doesn't really affect anything right now if you think about it. So how do we change this to a L'Hopital's rule? Well, a few of you might be looking at this step and saying, hey, well, couldn't we combine like terms here and make it 1 minus the cosine of 0 over, oops, I did theta, over the sine, cosine of x over the sine of x, and then plus the cosine. Pause a second here, sorry guys. Plus the cosine of x. And then let's get a common denominator here to combine these, okay? So then we're going to do 1 minus cosine of x plus sine x cos x all over the sine of x. So we just took this and we multiplied by sine of x over sine of x. And so now here's our term. And so now let's go ahead and evaluate the limit as x goes to 0 from the right of this. So we get, if we evaluate that, we get 1 minus the cosine of 0, which is 1, plus the sine of 0, which is 0 times 1, all over 0. And so you get 0 plus 0 over 0, so you get 0 over 0, and that, of course, is an indeterminate form, and we can L'Hopital right away. So when we L'Hopital it, we're going to do limit as x goes to 0 from the right of the derivative of the top of this over the derivative of the bottom of this. So the derivative of the top is going to be sine of x plus, and now we got to do product rule, so sine times the derivative of cosine is going to be negative sine squared x plus cosine times the derivative of sine, cosine squared x, all over the derivative of sine of x is the cosine of x. And if we plug 0 in, because I have a feeling we're not going to get 0 over 0 anymore, let's just see what we get. So the sine of 0 is, of course, 0, minus sine squared of 0 is 0, plus cosine squared of 0 is 1, over cosine of 0 is 1, and therefore you get just 1 over 1. So really, all we needed to do here was, in this step right here, realize that we could just get common denominators to put this all together, and once we have the common denominators, it's a pretty straightforward L'Hopital. As far as the concern of how do I make infinity over infinity into a 0 over 0, or infinity minus infinity into a 0 over 0 indeterminate form, usually it's just getting a common denominator.